slides back in. So, this talk is about pipeline as code. I gave this originally at DevOps Days London. I've given it a couple of days before. For those who were not in the previous slot, I'm Kris. I've been root causing these kind of conferences, and everybody shouts at me when DNS is broken. But that's not the topic today. Today I'm going to talk about automation. If we talk about DevOps and automation, we talk about all of these things. Build automation, test automation, infrastructure as code, monitoring as code, security as code, and today we also talk about pipeline as code. I'm going to use Jenkins as an example because that's the ecosystem I know. I know there's other tools out there, but this one is open source, so it kind of fits this conference. It's hugely adopted. There's a zillion plugins available, but it's really, really, really user interface focused, and it's an ugly one. So we have pipelines. We go from source code to production, and it's all automated. And we have lots of them. I mean, we've been building pipelines for years, and a lot of them are similar. Like we have patterns. A Drupal pipeline, a Symfony pipeline, a Java pipeline, a Python pipeline, a Node pipeline. You see? And they all have similar components, but sometimes they're different. And they're built by somebody, and that person moves on. So you have, in a lot of environments, Jenkins stacks with hundreds of pipelines and hundreds of jobs. And these are how they're built. You go to the UI, you create a new project, and you say, copy from. Who's been doing that? If we do this on operating system level, we say image sprawl, and it's going to fail, and it's going to be painful. And when we build pipelines, we do the same. And then we get stuff like complex pipelines, which go like this. So this one goes straight, and then they're split off, and then how do you build these? It doesn't scale. So we fail to maintain our pipelines, and we improve some pipelines, but we don't improve them all. Like you click on the one and you don't change it. So we start generating pipelines the ugly way. Jenkins uses XML. Who likes XML? So we templated the XML. Kind of worked, but not really. Then there's the OpenStack community with like Python-based approach. Kind of worked, but it was really limited, and a lot of the functionality we wanted didn't really work. So not really hugely adopted. Eventually the OpenStack community abandoned it themselves. And then there's a couple of other alternatives. Who's using Jenkins files? Who's going to use them? There's definitely need for this talk. Jenkins files typically live inside a repository. You basically write the definition of your job in Python, in Groovy. When we first started using them, they were pretty buggy. They have limited functionality, but they're really, if you've got an easy task and if you get a straight pipeline, they're really ideal to work. Oh, fuck, it drops off, whatever. Sorry. The alternative is basically using the Jenkins Job DSL or mix and match, and it's also Groovy. It's really flexible, and you're writing the code you want, and you can do more complex pipelines. So how do you deploy these jobs? Well, you have Seedjobs that actually allow you to generate all the different jobs which you're writing code. So you put Git in front of that, now you got source control on your pipelines. You've got them versioned, you know who changed what, you know who's breaking what, and you really can rebuild things on commit. So now you have a pipeline that actually builds your pipelines. Small example, this is basically definition of a job. You have the default parts in your job description, and if you have a whole project, there's different components, build, test, they're all jobs. You see, these are all parameters, so you just replace them. You generate everything. If you've got larger stacks, you use libraries, you reuse the libraries, you have different components, and each time you build a pipeline, you reuse the different components. Now, I talked about Jenkins. This is an example of how to do this in another tool. This is a GitLab CI example. So, one job per task, generated by code. You don't really rebuild different jobs. Each job has its own code base. Everything is in sync. If you update one, you update them all. And it's in Git. So basically, Stop clicking. Write code.
Oh.